Hello, welcome to lesson 3 of graphing lines. Right now we're going to work with writing equations of lines for the majority of this lesson. So let's look at the first page here and just see what we're working with. Now, quick refresher on slope-intercept form first. And this is a big deal, so we have to keep going. Slope-intercept, as we talked about in the first two lessons, slope is m. And what that is a change, if I can spell right, change in y over a change in x. Now the intercept is b, and that's the y-axis intercept, or just y-intercept for short. And that's where your graph is going to cross the y-axis. We don't worry too much about the x-axis usually. All right, so there's your refresher. Your x and your y are normally left completely open. We will be using them, but I'll show you how that works as we get deeper into our examples. All right. So first thing, for writing equations to lines, scenario 1, you're going to have questions that say write the equation of a line with a slope of, for instance, in example 1, -1/2, and a y-intercept of -2. You could also see that written as 0, -2. All right, so your y-intercept of -2 is going to be right here. Your slope, like we talked about, basically the map in the previous couple of lessons, the map is change in y over change in x. So that means down 1 and right 2. Now we're not so much worried about graphing right now, but here's the general trend of that graph. I don't have my line tool on, so it's going to be pretty crooked on here. Always use a ruler, never do that. So what we're worried about is writing equations though. So in y equals mx plus b format, again, here's your slope, and we're provided a slope, and here's your y-intercept, and we're provided a y-intercept. So this one's going to be nice and easy. Y equals -1/2 x, that slope is m, and y-intercept is b. Since b is -2, it's going to be -2. This is your equation of the line. And if you were asked to graph it, which sometimes you are, it would look as a neater version of what we showed here on our Cartesian plane. All right, let me get rid of this. For example 2, what we've got over here is a slope of 2. So instead of y equals mx plus b, what we're going to do is put your slope in for m, and we're going to put y-intercept in for b. So y equals 2x minus 4. That's it. Now, if you were to graph it, remember first you start out with your y-intercept of -4. 1, 2, 3, 4. Your slope is 2, which is 2 over 1. That means it's up to right 1 to get to the next point. 1, 2, 1, 1, 2, 1. So when you graph that, it's going to go up and through, just like this. And then, of course, you need your arrows at the end. So that would be the graph if you were asked to graph that. So that's by far the simplest because you have all the information that you need to write the line. Now let's look at examples when you do not. Scenario 2, say you're given a point and you're given a y-intercept. Now the point, here's what we haven't really talked about yet. The point is going to be an xy pair. And we'll use example 1 to get us started. So you have an x, you have a y, and you have a y-intercept. Now remember, this is b. So you have those three things. So what you need to find, what's missing, is m. All right. So if you're given a point and a y-intercept, you're going to have to find m. Find the slope. All right, to do that, think about where your y-intercept is. Is it -2? And I put a graph up here just to help me illustrate it. We're actually just writing equations, not graphing, but this helps me by knowing that this is 0, -2. So that's a point of the line. Another point on the line is negative 3, negative 2. And so if I'm looking for the slope, remember that slope equals your change in y over your change in x. To determine that given 2 points, and I have 0, negative 2, and I have negative 3, negative 2, I'm going to take one y and subtract the other. So we'll do negative 2 minus negative 2. Underneath, I'm going to do the same thing with the x's. Negative 3 minus 0. Once I do that math, two negatives turn to a positive. I'm going to have 0 divided by negative 3. So my slope in this case is 0. So when I write the equation, it's going to be, do it over here, right on top of the graph. The equation is going to be y equals 0x, and then remember b I already have as negative 2. Now we don't need this. 0x will always be 0, because 0 times anything will create 0. So my equation line is y equals negative 2. And that's it. Since I don't have an x in there, you won't see that. And if I connect these, you're going to see that's going to be a horizontal line. All right, let's clear off everything we did here. Now, if I can figure out how to do it. Get rid of all this mess. My clear page tool isn't working the way I want it to, so we'll just do it the old way. All right, for example 2. I've got a y-intercept of negative 1. Now for example 1, you know that that means that's 0, negative 1. On y-intercepts, x is 0. And you have 4 positive 2. So here's your 2 points. Again, you've got x and y. You have b. You're solving for m. So m is going to equal 2 minus negative 1, change in y, over 4 minus 0, or just 4. So 2 minus negative 1 is 2 plus 1 is 3. So it's 3/4. So m equals 3/4. Now I have everything I need to put this thing together. Y equals something x, and then your y-intercept of b. Now I kind of covered it up. It's hard to read, but my y-intercept was negative 1. My slope that I just found was 3/4. And that's it. Leave x and y open, because you can put an infinite number of x's and y's as long as they fall on the line that is graphed right here. All right, next scenario. You're given a point and a slope. So a lot of times these will be asked to for you to write the equation of a line with a slope of negative 1/2 that passes through point negative 4,5. So what you've got right here is you've got an x and a y, and you have an m. So got it, got it, got it. I need to find b in this case. I need to find my y-intercept. Now don't do it by graphing. You can't do it accurately by graphing, and very rarely does that work out. So let me show you how to get that done. For example 1, go ahead and write in y equals mx plus b format. Your y is 5 equals m is negative 1/2. X is negative 4. And b is my unknown. When you solve this equation, you found b. Now 2 goes into negative 4 twice. Negative 1 times negative 2 give you positive 2. So 5 equals 2 plus b. When I take 2 away from both sides, I get b equals 3. So now I've got b, I've got m, and when I rewrite I leave x and y open. I don't use negative 4 or 5 anymore. So y equals negative 1/2 x plus 3. It's easy to lose track of what you're trying to do within this equation writing. But if you're trying to find b, remember that's your goal. You're leaving x and y open. You want your equation to look exactly like this with the information that you have provided for you. So let's look at example 2. Do this again. Now slope, as soon as I see a whole number slope, I write it as a fraction. I don't know why, it just makes it easier for me. So in place of y equals mx plus b, I know already I'm finding b. We already talked about that. I'm going to put an x and a y there just to make sure I don't get them backwards. So I'm going to put negative 6 equals, in place of m, I'm going to put 2. I don't need to write it as a fraction this time, I guess. In place of the x, I need to put negative 5. And b is the thing I don't know. So 2 times negative 5 is negative 10. So I have negative 6 equals negative 10 plus b. To solve for b, I add 10 to both sides. So negative 6 plus 10 gives me that b equals 4. Now I have found b. I have my y-intercept. I was already given my m, which is 2. So that's all I need up here, because I'm going to leave y open, and I'm going to leave x open. So all I need is m and b to rewrite my equation in a line. So y equals, m originally was given to me as 2, x stays open, my y-intercept is 4. Now just a refresher on graphing, remember you graph y-intercept first if you're asked to graph. So go up to 4, make a point. Your slope is 2. That means up 2. And remember there's a 1 there, so that means go right 1. So up 2 over 1, up 2 over 1. And I'll use the line tool this time, make it look a little better. So if you were asked to graph, that's what it would look like. And your last scenario on this is, let's say you are given 2 non-axis points. Now what I mean by non-axis is that they don't fall on the y or the x-axis. So you don't have a couple of things. I have an x and a y. I have a couple of x's and y's. I can use either one I want. So I have this, but I don't have m and I don't have b. That's where it gets a little more interesting. So the first thing you're going to have to do is you're going to have to find a slope. Now you know how to do that given 2 points. So let's just look at that first. Slope is change of y over change of x. Let's do 6 minus 3 over negative 4 minus 2. That gives me 3 over negative 6. Now anytime you have a negative sign in the denominator, that just floats up to the top. So when I simplify this to 1/2 instead of 3 over 6, what I've now solved for is my slope. Alright, so I've got that. Now just like your previous example, I have a point I can use, either 2, 3 or negative 4, 6. So I have x and y, I have m. So first I found the slope, now I'm going to find b, and then I have everything I need to rewrite the equation. So if you're doing, again, it's y equals mx plus b, I'm going to multiply this negative 1/2 by an x value. Since they're both multiples of 2, it's easy to choose either one. I'm just going to choose my coordinate pair 2, 3. So 3 is my y, negative 1/2, x is 2, and remember b is what we're solving for. 2 times 1/2 is 1, so those cancel. 3 equals negative 1 plus b. Add 1 to both sides, and you get b equals 4. Now I'm ready to solve. So I have b, I have m, and that's all I need. So my equation of this particular line is going to be y equals negative 1/2, which is my m, x, my b is 4. Here's my equation. If I were to graph it, I'd start at 4. Start at your y-intercept right here. Negative 1/2 means down 1, right 2. And then I would connect these points. I'll use my line tool. Move that up just a hair. And that would give me my equational line. And again, we're not worried about graphing, we're worried about you knowing how to find the missing pieces, like recognizing what you have and what you still need. Alright, let's move on to example 2. We'll do this one in blue. We've already figured out that first you got to find slope. So find m. And that's going to be, we'll do 1 minus 2 on top. Change a y. And on bottom, change an x. So 2 minus negative 2. So it gives me negative 1 over 2 plus 2 is 4. So I've already found slope. Now once you find that, remember up here, you got to find b next. So to find b, I'm going to put it in slope-intercept form, y equals mx plus b, substituting negative 1/4 in. And let's use, I'm just going to pick a pair at random. Y of that pair is 2. M we discovered was negative 1 over 4. X is negative 2. And b is what we're solving for. Now right here, 2 cancels with 4, but I'm going to be left with a denominator. Don't worry about that. What you've got is 2 equals 1/2 plus b. So the way you solve for b is you subtract a half from both sides. Now don't do mixed numbers. 2 minus 1/2, we know that's 1.5. But what you want to do is convert 2 into 4 halves. 4 divided by 2 is 2. You need a common denominator to find b. So b equals 3 over 2. Now I've got b, I've got m. The equation on my line is y equals negative 1/4 x plus 3 over 2. And that's how you do it. Now if you want to graph that, if you want to graph 3 halves, that will be right there, about 1.5. Drop down 1, move over 4. It gets a little harder to do. What I would recommend is don't graph it that way. Graph using your points instead. It's far easier. If I graph 2, 1, and I graph negative 2, 2, then when I connect that, the line's just automatically going to go through the point that you found for your y-intercept. All right, so don't worry about graphing the y-intercept itself. That's going to work out without you even trying, right? Or it should. So this location should correspond to what you solve for b. All right, next, let's look at spatial scenarios, vertical and horizontal lines. Write the equation of a line passing through points 2, 5, and 2, 8. First, I want to graph those. You've got 2, 5, and 2, 8. Now, if I connect those, then you're going to see very quickly that's going to be a vertical line. No worries about you recognizing that. Let me go ahead and draw it in where it's proper. Now, writing the equation of the line is where some people have a big challenge. Now remember, this is your y-axis, this is your x-axis. A quick way of doing that is just recognize this x equals 2. And that's exactly what it's going to be. It crosses the x-axis at 2. It doesn't matter what your y is. And this has an undefined slope. If you mathematically attempt to find the slope, what you're going to have is 8 minus 5 on top, 2 minus 2 on the bottom, giving you a division by 0, and that's where your undefined comes in. Remember, anything divided by 0 is undefined. So you can't have anything times x. It's impossible to do that. So you just, you have nothing to go on. So this is one of the trickiest ones when it says write the equation of this line. You have to recognize you have an undefined slope. So there is no slope-intercept form. this is actually completely invalid up here, y equals mx plus b. It's only crossing x, so you're going to say where the line crosses x, and that's the extent of your equation. All right. Next, you have 5,2 and 8,2. So I'm going to start out graphing it. And a lot of times you won't be supplied a graph. It helps just to draw a little one off to the side of your problem, just to help you visualize what's happening. So I'm going to graph 5,2 and 8,2. Now, as soon as I connect those, I think you're going to see that that's going to be a horizontal line. Now, on here, you got y-axis, you have x-axis. You can still see that as just where does it cross the y-axis. It's straight. It doesn't cross x anywhere, so you're not going to have an x in your equation. It crosses it too. This is your equation. Now, this actually is slope-intercept form. That does fall in line. Where x equals is not, this does work. And the reason for that is if I find the slope of 5,2 and 8,2, I'm going to have 2 minus 2 on top, and either 5 minus 8 or 8 minus 5 on the bottom. 0 divided by 3, or negative 3, will give me a slope of 0. So if I put it in slope-intercept form, it's y equals 0x plus 2. 0 times x, regardless of what x I put in, it's going to cancel this out. So that's where my y equals 2 comes in. It crosses the y-axis at 2. It doesn't cross x. Therefore, your equation is y equals 2 and you're done. Just two other special scenarios that we need to get out of the way, and that's parallel and perpendicular slopes. So the first one I want to talk about is, let's just graph these lines. That way you kind of see what's going on. First one is going to be parallel lines. Now you notice something that you've got. If I graph these lines, remember first graph your y-intercept. This y-intercept is at 1. Then my slope is 2 over 1. It's 2, meaning up 2, right 1 from the line from the point I just plotted. Let's just get this graphed and see what happens from there. Right, so there's our first line. Now our second line is y equals 2x minus 3. So my y-intercept here is at negative 3. But my slope is still 2 over 1, which still means up to right 1. Now what you probably notice about this is you've got parallel lines. They will never cross, right? As soon as you see two lines that have the exact same slope, you know those will be parallel. Occasionally you'll be asked to graph a line parallel to another line. Then you'll just recognize that that line is going to cross at a different place on the y-axis. So your y-intercept will change, your b will change. But your slope will not if you're looking for parallel lines. In contrast, let's go to the next page. Sometimes you'll be dealing with perpendicular lines. So let's graph these lines here. We'll do this one in black, and we'll do the next one in blue. Again, first, graph your positive 1 y-intercept. Now I need to graph negative 1 over 2 slope, which means down 1, right 2. So down 1, right 2, down 1, right 2 more. Let's go ahead and make that line. Straighten that up with my lines just a little bit. And put the arrows in. So there's line 1. For line 2, I've got a y-intercept of negative 3. So I'll always start out there when you have it provided. My slope is 2, which is 2 over 1. Positive 2 means up 2 on y-axis. And right 1. So up 2 over 1, up 2 over 1. And I'll put another one in there. I put that line in, and we'll just see what happens. Tell you what, it didn't come out just exactly the way it needs to look for this example. Let me try that again since I broke that into a couple pieces. One more time. That's a little bit better. Alright, what you may run into is either a graph or a listing of two lines like we have here. But what you want to look for is you're interested in the slopes themselves. If you're trying to determine if lines are parallel or not, what you want to do is multiply your slopes. So you got negative 1/2 times 2. What you'll have is negative 2 over 2. That gives you negative 1, or you can just cancel those out to get that answer. If you multiply the slopes of the two lines and it equals negative 1, as it does in our example, then that proves that those lines are parallel. And not parallel, excuse me, perpendicular. So those are going to meet at a 90-degree angle in all four corners. Now you'll work more with that when you get into geometry, trigonometry. But right now just recognize that they need to multiply together to give you negative 1. And they're going to be opposite reciprocals. So if you have a slope of 3, the other line would have to be negative 1/3. If you have a slope of 1, the other line would have to be negative 1. Alright? And those would give you perpendicular lines. That's not going to be something you have to cover a whole lot, but it may pop up. Alright, let's see. We have already covered these, I do believe. Let's do it one more time just in case. If you are graphing x equals and y equals equations, you have y equals negative 2. I'm just going to put a negative 2 here. And just roughly freehand draw those, because I think we've already covered that. And then for x equals 3, on the x-axis, go to 3. And the only way to cross x is if that line goes up and down. So there's your two lines there, in case we haven't covered that. Just quickly show you there. And that's about as far as I want to go into that one again. And let's see, that's, I believe that's it. I think I just had an extra page in there I didn't mean to have. So, great. I think we're back to the start. So in the next section, we're going to get a little deeper into inequalities for lesson 4, and that will be about it for chapter 3 of Algebra A. Now, for Algebra 1 students, you don't want to quit yet. There's one more on working with systems of equations you need to see. Algebra A, you're going to do that in chapter 4, so that video might be helpful once we get to that point, but you won't have to see that yet. All right? So move on to lesson 4, and that will cover the last part of graphing linear inequalities.